Okay, let's real quick go through these electricity questions. I got my calculator out. I got my red pen. What is the current? 1,700 coulombs of charge passed through a point in 75 seconds. Current is I. Formula is equal to charge Q over time T. Charge is in coulombs. Time's got to be in seconds. No conversion needed here. That's coulombs over 75 seconds. So let's go 1,700 divided by 75 equals, we'll say 23 amps. Next one, calculate the amount of charge that flows through a 12 amp motor in 2 minutes. Same formula, I equals Q over T, except now we're calculating charge. And I'll just draw this triangle off to the side for those of you that like that. It's I, Q, and T. So if I want to solve for charge, I got to go current times time. Charge equals current times time. So that's 12 amps. So current, 2 minutes, but 2 minutes is 120 seconds. 12 times 120 equals 1440 coulombs of charge. It's determined that 34 coulombs of charge transferred 1,500 joules of energy. Determine the voltage. Voltage, or potential difference, is V, and it's equal to energy over charge, or joules per coulomb. So that's 1,500 joules, 34 coulombs. Gives me 44 volts. Extend the page a bit. What's the resistance of a toaster that draws 9 amps when connected to a source of 120 volts? That's voltage, that's current. It's R equals V over I. So in this case, that's going to be 120 volts, 9.0 amps. 120 divided by 9 equals 13 ohms of resistance. What's the voltage across a 73 ohm resistor if 0.75 amps are going through it? That's V equals I times R. Same formula, Ohm's law. If you want the triangle, here it is, V, I, and R. So I times R. In this case, that's going to be 0.75 amps times 73 ohms. And that's going to give me a potential difference, or voltage, of about 55 volts. Next, we'll talk about adding resistance. And before I do anything else, I'm just going to go look at what the questions were on the review here. If I just scroll up. So a 12, a 15, and a 23 all in series. 12, 15, and 3 in series. So I go back over here. For resistors in series, I just had them all up. So I just go total resistance, 12, 15, what was that other one? And 23. 23 ohms, 12, 15, 23 equals 50 ohms. There we go. The other one's set up in parallel. And parallel resistors have to use a little bit different method to add them up. This is a 2, an 8, and a 9. In parallel, I've got to go 1 over them. So 1 over the total plus 1 over 2, equals 1 over 2 plus 1 over 8 plus 1 over 9. All right, so I go on my calculator and add those up. I type into my calculator 1 divided by 2 plus 1 divided by 8, 1 divided by 9 equals, gives me like 0.736. So that's what 1 over the total is equal to, 0.736. All right, that's not the answer though. I got to press the X to the -1 button on my calculator to flip it around and get the actual total resistance, and it's 1.36. So RT equals 1.36 ohms. There's the answer there. Next, what's the power of a device that draws 3 amps, 12 volts? Power. Power equals energy times time, or current times voltage. So that's 3 amps times 12 volts. And that's going to be 36 watts. Stereo draws 0.24 amps, 120 volts. What's the power? Same exact formula. Power equals current times voltage, so 0.24 amps times 120 volts. That one I need the calculator for. 0.24, 120. It gives me 28.8 watts. What's the resistance of the stereo? You can do that too. R equals V over I. That's 120 volts, 0.24 amps. 120.24 gives me 500 ohms. It's left on for 2.5 hours. How much energy is it used? Well, energy can be found by going power times time. We have the power, it's 28.8. The time is 2.5 hours. But I don't want to leave this in hours. I'm going to put it into seconds. Times 60 would give me minutes. Times 60 again would give me seconds. That's going to give me an answer in joules. So I got 28.8 times 2.5 times 60 gives me 259,200 joules. There it is. We could have did this in kilowatt hours, and I would have to give you full marks, but we don't have to do it in kilowatt hours. Easiest here, I think, just to leave it in joules. Draw a graph of voltage versus time for AC and DC electricity. I don't even like the way that that's worded. It should be actually current over time. The potential difference actually stays more or less constant. It's the current versus time. Anyways, for AC, I, this is time. Alternating current basically looks like a sine curve. All right, it goes back and forth, into the negatives, into the positives, into the negatives, into the positives. That actually looks a little ugly. Should go as far into the negatives as it does into the positives. Should be a nice smooth sine curve. That looks a little better, like that. Whereas direct current always just gives you a constant current. Current, time, that's constant the whole time. Negative, positive, that part doesn't really matter, but it's always going to be a constant current. All right, 400 watt furnace, 6.8 hours a day. There's the cost, and we got 60 days. So I don't know, what do I want to do first? When I'm dealing with cost, we pay in cents or dollars per kilowatt hour. So I want my energy in kilowatt hours. So that means I want my power in kilowatts and my time in hours. So first of all, the power, 400 watts, is equal to 0.400 kilowatts. All right, that's done. The time is in hours already, 6.8 hours per day, but it's for 60 days. So overall, I've got 6.8 hours a day times 60 days, which gives me a time of 0.8 times 60, 408 hours. Now I've got my kilowatts. Now I've got my hours, so I can find my energy consumption in kilowatt hours by just going 0.400 watts times 408 hours. That gives me 163.2 kilowatt hours. That's not my cost. That's how much energy I used in kilowatt hours. If I want to get a cost, you just go energy times the rate that the question gives you. In this case, our energy is the 163.2 kilowatt hours times 7.5 cents. If we want an answer in cents, sure, we'll go 7.5 cents. So I take my 163 times 7.5, gives me 1224 cents, which is the same as $12.24. Next one, some voltage and current data. I can't remember exactly what the questions were, but one of them will be graph it. A couple of things to know for that is V always goes on the y-axis, and I goes on the x-axis. All right. So I guess I'll just plot some points. I don't know. It's going up to 14.7, so I'll count maybe by twos. I'll make this 0, and we'll go 2, 4, 6, 8, 10, 12, 14, 16. So that's 2, 4, 6, 8, 10, 12, 14, 16. There's my voltage. Current goes from 0 to 0.57, so it makes sense if I just go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. I'll write those in, 0.1, 0.2, 3, 0.4, 5, 0.6. Now I'm going to graph this stuff. So I got a point at 0, 0. I got a point at 0, 0. Put a circle around it, one of those error circles. At 0.12 amps, I've got 3.1 volts, so somewhere around there. At 0.25 amps, I've got 6.4 volts. 6, somewhere around there. At 0.4 even, I've got 10.4, right up to about there. And at 0.57, I've got 14.7 volts. So that's going to go right around here. Don't forget to make a line of best fit. It's going to be hard for me to freehand that on the smartboard, but there's a line. Actually, I did pretty good. Other things you'll have to calculate with that would be find the resistance from the graph, right? So you have to know that R equals slope. So in this case, you could go, since there's a 0, 0 point, you could go 14.7 volts over 0.57 amps, and that gives me a resistance. 14.7 divided by 0.57 gives me about 26 ohms. All right. The color bands that it gives you, I think, ends up giving you 23 ohms. All right. So if I want to do a percent deviation, you go experimental minus theoretical divided by theoretical times 100. So that would be 26 minus 23 over 23 times 100. And that gives me a deviation, 26, 23 divided by 23 times 100 gives me 13%. If you were asked to do kind of reasons that we got a higher than expected resistance, see the value from the data is 26, and it should have been a 23 ohm resistor. So possible reasons the resistance could increase is due to the heat generated in our circuit. Could be the resistance of the wires themselves adding to our overall resistance in this experiment. Or it could be the percent tolerance of the resistor itself. Remember, resistors are, the ones I gave you are only designed to be within 5%. They can deviate 5% from the true value. It doesn't account for all 13% of our error, but that could be some. And I think the fourth band was gold or something, so that would have been like a plus or minus 5% on those resistors. That's that one. Let's see what else we got to cover. Solving circuits. This part's my favorite. All right, let's switch colors. Let's go blue. So I got 3 resistors in series. So I'm going R1, R2, R3, just 3 resistors, and a total. And each of those will have a current, a voltage, a current, and a resistance. like so. It gives me some things to begin with. It gives me the total voltage. It's 54 volts. It gives me the current in R1 is 3 amps. And it gives me that the resistance on R3 is 7 ohms. 7 ohms. One more thing, 9 volts on R2. There we go. I think I got everything now. All right, well, the first thing I would say is that in series, if 3 amps of current go through that resistor, 3 amps of current is going to go all the way around and hit all those resistors. All 3 amps that go through R1 will go through R2, will go through R3, and also go through the source. So 3, 3, 3, all the way down. Now we can figure out some things because V divided by I equals R. So 9 divided by 3, it's not 6, it's 3. So I know that resistor's got 3 ohms. Now what do? Right here, I've got V equals I times R. 3 times 7 is 21. The last thing you got to do is think about the voltage loop rule. If I gain 54 volts at the source, then I have to lose that much through all the resistors. So far, I've lost 21 and 9. How much more did I have to lose? And I think the answer is 24. Yes, 24 volts. And the last part, 24 over 3. Sorry, I got interrupted there and paused it quick. Mr. Edgar came in. 24 over 3 is 8. 8 ohms. Oh, we still got to do the total resistance. You can do it by going 54 over 3, or you can just add up those resistances. 15 plus 3 is 18. Either way, it should give you the same value. Otherwise, we did something wrong. There it is. That's a series circuit. Let's do a parallel circuit. There it is. Make the same chart, except this time I only got 2 resistors. R1, R2, and RT. V, I, and R. So I got 9 volts through the first resistor. There we go. What else I got? Nothing. Just that the 2 resistors are equivalent. That I'm assuming that's going to come in handy, all right? In parallel here, each loop only has 1 resistor. So if I dropped 9 volts at this resistor, then I must have gained 9 volts at the source to begin with, because that's the voltage loop rule. Whatever you gain at the source, you have to lose in the path. And in that path, there's only 1 resistor, so there must have been a 9-volt gain at source. And if there's a 9-volt gain at the source, and I go the far path, then there must be a 9-volt drop at R2. They're all 9. Some people choose just to memorize it in parallel. The voltages are always going to be the same, and that works here. What else I got? Anything? I got 2 amps. I missed that. 2 amps in R1. So I'm putting 2 amps there. So V divided by I, that's going to be 4.5 ohms there. It does help, I guess, in this case. It says R1 equals R2. So it's also going to be 4.5. 9 divided by 4.5, it's going to be 2 amps there also. So how many amps came from the source? If I got 2 amps here, 2 amps here, then I must have had 4 amps come from the source, because at this point they split up and some go that way and some go that way. So that's going to be 4. 9 divided by 4, I think, is 2.25. You might want to check my math on that one, but that's what I'm getting. One more and then done. This is a combination circuit. I'm not going to give you anything on the exam that's more complicated than this, I don't think. So let's make a chart for it. I got this time 4 resistors, pretty big one. R1, R2, R3, R4, and of course R total. V, I, R. Line, line, line. Move this over, move this over, move this over. There we go. What's the question give me? It gives me 3 amps through the first resistor. Just cleaning up some stuff. 3 amps. That's right there. Let's switch colors. Let's go to blue. The third resistor has 5 ohms. I see that. So that's going to be here. Actually, it gives me all the resistances, doesn't it? 25, 10, 5, 15. It gives me the 3 amps, and it gives me nothing else. All right? So you got a couple of options right away. You can go 3 times 25. It gives me 75 volts through R1. Then I can add up the resistances. That's the tricky part. If you get that right, the rest of the question isn't too bad. But if you don't get this right, then you're out of luck. So 5 and 15, these two guys are in series. They don't look like they're in series because they're not on the same line, but they're in series. They're both by themselves on that path, all right? So that makes 20. 5 and 15 makes 20. When they're in series, you just add them up. Now I've got 20 ohms and 10 ohms in parallel. To do that, I got to go 1 over RT equals 1 over 10 plus 1 over 20, and then solve for RT. If you do that correctly, add those fractions up, and then flip it, you end up with 6.67, I think. Again, you can check with your calculator, but I think that's what it is. So this whole rectangle gives me a resistance of 6.7. So it's as if I've reduced the circuit to just this. One resistance there, like that, where this one's 25, and this one is 6.67. That's what I've done by adding those resistances up. Now I've just got two resistances in series, 6.67 and 25. If I add those two up, then I'll have the total resistance, and adding those two numbers is 31.67. It's actually 6 repeat, but I rounded that last digit to 67. And then it looks like I'm stuck. Now what? Here, 3 amps go through R1, so how many amps came from the source? It doesn't split up before it gets there, so 3 amps came from the source. 31.67 times 3 is 95 volts. Now I got to do some thinking again. Let me just take some of this stuff off so we can look at what we're doing again. We're done sorting out the resistances. If you need to see that again, you can look back at it. So I got 75 volts here. I got 95 volts here. And I'm looking at the path that goes like this. So how many volts did I drop at R2? Drop 75 there. Of the 95, that means I must have dropped 20 volts at R2. Where's R2 here? It's 20. 20 divided by 10 is 2. So I got 2 amps. Again, I want to clean it up a bit. And let's have a look at the current. 3 amps go through this resistor. That's called a junction. Some of those 3 amps go that way. Some of those 3 amps go through those other 2 resistors. We just found out that 2 amps go this way. So how many amps go this way? 1 amp. And it'll go through both of those resistors. 1 and 1. 5 times 1 is 5 volts. 15 times 1 is 15 volts. And that's how you solve a combination circuit. I'll make one more video, but I'll probably do it on, I'm running out of time here today. I'll probably do it on Monday or Tuesday. So look, if you're watching these videos, then look back